Welcome to this explainer. Today, we're breaking down the exact strategies you need to master Cambridge Biology 9700. We're going to skip the generic study advice, right? Instead, we're going straight to the source material to decode the examiner's mindset. We want to show you exactly what top-tier candidates are doing differently. So let's dive right in by exposing the one critical error students make regarding substrate concentration. This is the mistake that literally tanks exam scores right out of the gate. You know the feeling? You sit down, you see a complex, multi-step biological pathway, and your brain immediately rushes to the final calculation. But skipping that initial setup, that's exactly where the trap snaps shut. Think of substrates as the raw materials, like the fuel in a biological factory, and the enzymes are your workers. If you don't correctly identify how much fuel is in the factory before the machinery even turns on, well, misinterpreting those initial conditions costs you the top grade before you've even written a single word. And why does this specific trap matter so much? 15%. This single topic accounts for a massive 15% of your total marks in paper 2. That's not just some minor detail, that is a grade-defining chunk of your exam. The stakes here are incredibly high. Mastering exactly how substrate concentration impacts reaction rates is absolutely essential if you want to secure that top band. You just cannot afford to leave 15% of your marks up to chance. All right, section 3.2. Effect of substrate concentration on reaction rate. Now, ordinary revision totally fails here because it focuses entirely on memorizing textbook definitions and completely ignores how examiners actually award marks. You see, the assessment framework prioritizes analytical depth. Examiners don't just want you to memorize what a substrate is, they want to know if you understand what happens when all the enzyme workers in that biological factory are suddenly overwhelmed with too many tasks. It's really about connected understanding, applied to completely unfamiliar contexts. To actually grab those high marks, you need to rely on a 3-step problem-solving framework. This is what top-performing candidates use to process all that complex data. Step 1, deconstruct the given information. Literally, pull apart the graphs, the tables, and the specific context they give you. Step 2, solve systematically in logical steps. And Step 3, evaluate and justify with evidence. You have to check for reasonableness and make justified recommendations. It isn't just about finding an answer, it's about proving exactly how you got there. Now, in just a second, I'm going to show you a hidden examiner clue that completely changes how you handle calculation answers. But first, you've got to internalize this urgent warning straight from the principal examiner report. Listen to this. Candidates consistently confuse key terminology. It's kind of an open secret in the grading room. If you launch into an extended response about reaction rates without first precisely defining your terms, you are bleeding marks. You always have to set the foundation first. And this whole idea perfectly illustrates what we call the method mark strategy. Did you know examiners actually award points just for showing a clear, systematic processing sequence? Identify the key elements, apply relevant biological principles, execute your analysis with super clear working, verify your results, and present it in an appropriate format. Cambridge examiners want to see the architecture of your thoughts. If you make a tiny math error at the end, but you've clearly documented this exact sequence, well, the method mark strategy ensures you still pick up the vast majority of the points just for the process itself. Okay, let's look at the top 3 costly mistakes. Having a structured approach is basically your shield when that exam clock is ticking down. In fact, when we analyze the report specifically for section 3.2, the data on where students lose easy marks is genuinely shocking. It's almost never because the biology is too hard. It's because of easily preventable structural errors. So let's look at exactly what they are so you never make them. Here they are. Number 1, forgetting to include units in your calculations. Literally, you could calculate the absolute perfect reaction rate, but if you leave off the units, the examiner will ruthlessly give you a 0 for that mark. Number 2, failing to check units and terminology. Mixing up your millimoles or misusing a word like affinity is an instant red flag to the examiner that you lack precision. And number 3, writing answers not specific to the context given. If the question gives you a specific biological context, say an enzyme in a deep-sea bacteria, and you just drop a generic textbook answer about substrate concentration, you're throwing away easy marks. You absolutely must tie your answer directly to the context given on the page. Moving on to the open loop, essential statistical analysis. Let's dig into the hardest material and uncover that hidden clue I promised you earlier. Data interpretation and statistical analysis. This is where top-performing students really separate themselves from the pack. When you're handed raw data about substrate concentration, you aren't just expected to describe it. You're expected to analyze it statistically. This is the exact hurdle where most candidates just freeze up. But with the right framework, this isn't some boring math chore. It becomes your ultimate secret weapon for securing top marks. You absolutely have to memorize this exact mapping of statistical tests to biological data types. It's a game changer. If you're comparing means between two different substrate concentrations, you use a t-test. If you're dealing with categorical data, that's chi-squared. And if you're looking for relationships between variables, like how increasing substrate concentration correlates with an increase in reaction rate, you need correlation tests. Memorizing this mapping allows you to calculate relevant statistics and draw evidence-based conclusions instantly. All right, spot the error, the exam climax. Let's escalate the stakes a bit, because it's one thing to know the theory, but it's a whole other beast to apply it when the clock is ticking. We're going to apply this entire framework to a typical Cambridge-style exam response right now. Let's put you in the examiner's seat. Can you instantly spot where a candidate threw away their 15%? Check this out. Notice how the flawed answer on the left loses easy points. It's a vague, unitless mess that completely ignores the biological context. It's basically a generic textbook answer. Now contrast that with the surgical precision of the top band answer on the right. This student perfectly executes the method mark strategy. They define precise terminology first, they show clear calculation working with verified units, and crucially, they integrate cross-topic connections. This is exactly what the principal examiner is begging to see. To write that top band answer every single time, you need a repeatable formula. The candidates who pull the highest grades always follow this logical progression. First, start with the core concept. Second, provide evidence or data extracted directly from the tables or graphs they give you. Third, apply scientific reasoning to connect that concept to the data. And finally, match the examiner wording. Question your assumptions and justify your decisions with concrete evidence. If you follow these 4 steps, your answer becomes pretty much bulletproof, no matter what curveball the exam throws at you. But hey, this brings us to a rather urgent diagnostic cliffhanger. You can study this explainer, you can know the biology of section 3.2 inside and out, and you can map your statistical test flawlessly. But what happens if you completely misunderstand the command word at the very start of the prompt? Think about it. If the examiner asks you to evaluate and you only describe, you can have the most perfect biology in the world, and you're still going to lose the majority of the marks. Knowing the science is really only half the battle. Knowing what the examiner is secretly asking is the true key to unlocking that top band. So before you dive into your next practice paper, I want you to ask yourself a very serious question. Are you just memorizing biology, or are you finally learning how to decode the exam itself? Make sure to subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCS, and click on the next explainer right now to master the command words that will totally dictate your final grade. We'll break down exactly how to decode what the examiner actually wants from you. See you there.